Welcome to virtual GED class. Today we are just straight up doing a review, looking at all the interpreting word problem skills that we've been learning over the last few weeks. We're going to be putting them together. So we've learned to use units to help us interpret the word problem. Knowing what unit you're in and what unit you're looking for can be super helpful. We've learned to substitute simpler values. We talked about choosing the correct operation, how to know when you're adding, subtracting, multiplying, or dividing. We have talked about visualizing, using pictures to help us interpret word problems. So I am not going to have an agenda today with how we solve. We are just going to look at some typical GED style word problems and see if we can use these skills to figure out what's going on. So let's get started. So let's look here at these examples. So just a quick helpful reminder to everybody today, you are welcome to use your TI-30XS as we go through these problems and the GED formula sheet, because when you're taking your GED test, it's the same thing. Pretty much whenever you're interpreting word problems, you got your calculator, you got your formula sheet, so you just need your reasoning skills. So here we go. Number one, Mike has $400 to spend on music lessons. If there is a $65 one-time enrollment fee and lessons costs $55 each, how many lessons can he afford? Now, whether you realize it or not, this is perhaps the most popular type of word problem on the GED. Popular because it actually relates to lines. People don't realize it, but that's okay. You don't have to know anything about lines in order to do this one. All you have to understand is the basic operations. So let's go ahead and take a look. It says Mike has $400 to spend on music lessons. We see that we have a $65 one-time enrollment fee and lessons cost $55 each. And then our question here is, how many lessons can he afford? So as far as I'm concerned, all we need for this particular problem is a little bit of information about the basic operations. Does anybody have a place where they want to start that I should launch off from?
I would subtract and then divide.
You would subtract and then divide. I would subtract and then divide too. What drew you to subtraction and division?
Because you have a one-time enrollment fee,
Mm-hmm.
then you want to know how much that extra money left over will go towards the lessons for 55 times.
And which one did you want to subtract? Was it the one-time enrollment fee or was it the lesson cost?
The one-time enrollment fee, because it only happens.
Yeah, I absolutely agree. Since we're only paying that one time, whenever we talked about the basic operations, we said that when something happens just once, we're either adding or subtracting. In this case, we are subtracting, like Nicole said. Why? Well, because this $400 here is the total that this gentleman has to spend. We've got a total of $400 and we're breaking it down. Now we've got two ways to break down a total. And that's kind of what I was fishing for when I asked Nicole, why were you wanting to subtract and divide? Well, when we have a total and we want to break it down, we can subtract an amount out, or we could break a total into many size groups by dividing. So I absolutely agree that I'm going to subtract that $65 fee. And then I love that you said and divide, because this lessons cost $55 each. That's a payment that we're paying over and over and over again. We're taking a total this time and breaking it into same size groups. So I absolutely agree with you. So I'm going to start with the subtraction. Let's pay the one-time fee first. So I'll take it that $65. And again, you could do this in your calculator. So I get $335 after I pay my one-time enrollment fee. And then you said that you wanted me to divide. Now, order matters when I divide, Nicole. What did you want me to divide with or by?
335 divided by 55.
Absolutely. We always start with the total when we're dividing by. So take that 335. That's that total we have left. And we're going to divide it by the $55 each. Okay, so let's do that. 335 divided by 55, and I get this out of my calculator, 6.090909. As often happens in word problems, there aren't any specific rounding directions in this problem. It doesn't say round to the nearest 10th or 100th, but I say that common sense, thinking about this unit, should tell me what to round to. So this is 6.09 what?
Lessons.
Lessons, absolutely. So let's imagine that we were getting music lessons. We walked up to the music teacher and we said, we had enough money to pay for 6.090909 lessons. What's the music teacher gonna do? I mean, how many lessons are we gonna get?
6.
6. We're only going to get 6 lessons. Exactly. Nobody's going to give us a part of a lesson because we have part of the money. And so we'll say he can just afford 6 lessons. Is that problem easy?
Yes.
Good. I absolutely guarantee you'll see something like this on the GED because, like I said, it's an application of linear equations, lines. Basically, whenever you have something that happens just once, and then another thing that's happening repeatedly. So in this case, we have a one-time fee and a repeated fee, but it makes a line. It draws a line. And so we see word problems like this quite frequently. So let's look at the next one. It says for numbers 2 through 4, use the table below. The table shows the elevation of several California locales in feet. And first, number 2 says, what is the median elevation of the locales featured in the chart? You know, some of us have done the data analysis unit and some of us have not. We talk about what mean, median, and mode are in that unit. Ladies, do you guys know what median is?
The number that is in the middle.
That's a great way to think of it. It's one of the ways of looking at the middle of a list, absolutely. And it is the centermost number in an organized list. But I have really, really good news for those of you who don't know that. It is on the GED formula sheet. If you look on the GED formula sheet, right in the middle, it says median. Median is the middle value in an odd number of ordered values of a data set, or the mean of 2 middle values in an even number of ordered values in a data set. This one's a very straightforward problem at first, but we have to order the data set. Whenever you do a median, it's the middlemost number in an ordered list. So I am going to need to order the elevations here. Okay, guys, help me out. If I'm ordering these elevations, which one is the smallest elevation or the lowest?
Mine is 282.
Good. We got to get our negative values down. Oh, I thought I was going to throw you with my negatives. And then we have
10.
Oh, I see one smaller than that.
Yeah, 185. I just did one list.
Oh, you didn't notice that there's lists on either side. Oh, gotcha. Okay, so then a 10.
10, 20, 20.
20, 20, yes. And
30,
then
33.
55.
100, 225, and 1200.
Beautiful. And now, and I like that we're practicing median because this concept can come up on your science, your social studies, or your math. Now we're supposed to find the middle number. So I go one off the top, one off the back, one off the front, one off the back, one off the front, one off the back, one off the front, one off the back, and uh-oh, I've got a problem. 2 in the middle. Now I just read that off the formula sheet, but a lot of people struggle when there's 2 in the middle. Anybody know what to do?
Add and then divide by 2.
Absolutely. It's like a mini mean, as I call it. I'm going to add together 20 and 33, and then after I add, I will divide by 2 to get the exact center of that list. So let me just write down what I'm doing. 20 plus 33 divided by 2 gives me 53 divided by 2, which is 26.5. So the median elevation here is 26.5 feet. So let's look now at number 3. Number 3 seems like a simple problem, but so many students mess it up. So let's look. It says, what is the difference in elevation between Beverly Hills and Death Valley? Okay, you guys, let's talk about difference. Now, we're supposed to be finding the difference between Beverly Hills. So let's see Beverly Hills elevation, 225, and Death Valley's. And Death Valley's is negative 282. Now, I got to tell you the truth that a lot of students mess up word problems that have negatives in them. So I'm just going to imagine what I would do if these were not negative numbers. You know, if Death Valley was not negative. So let's pretend Death Valley was like at 10 feet. So guys, if I wanted to find the difference between Beverly Hills and Death Valley, and I had positive numbers, so that's like what we tried with our substituting simpler values, what would we do to find the difference between those two numbers?
Subtract.
We would subtract, absolutely. And with subtraction, order matters. What number would you start with?
The largest.
The larger number. So she says, I would start with the larger number and then I would subtract the smaller number. Okay, let's try that. So we now will use our real numbers. So what is my larger number of these two?
225.
225 is the larger of the two values. 225 is more than negative 282. And obviously, you know, if I didn't have the negative sign on it, 282 would be higher. But if I'm that much, like if I'm in debt, $282, that's a very that's not having much money at all. I'm poor. Or in this case, if my elevation is negative 282, that's very low. It's a low number. And now from that, I'm supposed to subtract. What am I supposed to subtract? My smaller number. What is my smaller number?
Negative 282.
Negative 282. Beautiful. I want you to notice what I've written right here. Now, this freaks a lot of students out. Can you read this expression that I've written? What does it say?
I don't know how to explain, but now we have to add it.
Yeah, it does turn into addition. You're right. Let me read it first, Maricela. This says 225 minus negative 282. Now, you have a calculator when you go to do this. So Maricela knows how to do this by hand. But even if you don't, if you type 225 minus negative 282, your calculator will give you an interesting number. It will give you 507. And that's because your calculator knows something that Maricela also knows. And that's that if one of my towns is 225 above sea level, and the other one is 282 below sea level, the difference in their altitude is a big number. It would give me 507. And we can look at that using our visualizing video, using our substituting simpler values, a lot of ways that we can see that. Is anybody mad at me?
No.
I'm going to ask a question. It's probably stupid.
No. Ask me a question because this is one of the problems that screws up the most students, Nicole. So ask away.
So the negative 282, why wouldn't we just put negative 282 rather than adding
like
another?
225 minus 282?
Yeah.
Okay, so if I wrote that, I'm taking 225 and I'm minusing positive 282.
Positive, okay.
But I wanted to minus negative 282. And students who do this by hand, who know about adding and subtracting negatives, know that subtracting a negative is synonymous to addition. So they'll just change that minus to a plus. So they know in the end, the difference does turn into addition. But that is because subtracting a negative number, which is what I'm doing, is the same as addition. And so this is not, though. Notice if I did 225 minus 282, it gives me an answer that doesn't even logically make sense. It says they have a negative 57-foot difference. Like, we knew my difference wasn't supposed to be negative. Difference is always positive. And then those two things aren't only 57 feet apart. They're really far apart. One's way up here and one's way down there. It's confusing to students because they want to go straight to the addition, but I'm trying to show you how difference really could turn into addition, the difference between a positive and a negative number. So number 4 says the elevation of Ventura, California is how many times that as the elevation of Santa Cruz? The elevation of Ventura, California is how many times? Well, I kind of feel like from our choosing the correct operations skill that right there, we should know what we're supposed to be doing. How many times? When do we ask ourselves how many times?
We have to multiply.
Okay, so let's set this up as a multiplication problem.
Divided, I'm sorry.
Well, you know what though, Maricela? I was making it to the point that this is really a division problem, but most people start with times. So let's see how we're both kind of right. So Maricela said, well, it says how many times. So it should be some number of times. So the elevation of Ventura, California is how many times that as the elevation of Santa Cruz. So they're saying if I start with Santa Cruz, 20, how many times would I have to times that by to get to Ventura, which is 100?
5.
Absolutely. And so if I ask myself 20 times what? Yeah, some of us can do that math in our head. Now, what are we supposed to do if we can't do that math in our head? Maricela knows the inverse or the opposite of multiplication is division. We could start with what would have been our answer, the 100, divide out the 20, and I do get 5. So whether you think of this as multiplication, and you're just asking yourself, what number am I multiplying by? Or if you think of it division, how many times does it go in? We end up with the same answer. Well, and one of the confusing things here is there's not one right way to think about this problem. It's going to be the fastest class ever. You guys are like, we're really good at word problems, so we don't need this class.
They're my favorite.
And we have a lot in the GED.
Yes. They like them on the GED, don't they? So let's look at number 5. A merry-go-round is a spinning disc 3 meters in diameter. How far would a child clinging to the outside of the merry-go-round travel in each rotation of the wheel? I wanted to do a problem like this. The GED likes them, for one thing. But I wanted to do one like this because I don't think that it's easy to tell what's going on here without drawing a picture. So first thing I see is a merry-go-round is a spinning disc 3 meters in diameter. What am I drawing here, guys?
A circle?
A circle. And they gave me a measurement on my circle. They said it's 3 meters in diameter. Anybody remember what the diameter of a circle is?
Is one side of the center?
Just one side to the center is the radius, but the diameter goes all the way across.
Across, okay.
Is that good? So we have a diameter that's a spinning disc 3 meters in diameter. Okay, wonderful. Now it says, how far would a child clinging to the outside of the merry-go-round travel in each rotation of the wheel? Okay, you guys, where is this child going to travel if he's clinging to the outside of the merry-go-round? Let's put him there. How's he going to travel? I'm not looking for a number. I'm looking for you to describe to me, like, where's his traveling going to happen?
Around.
Around, absolutely. This kid is going to spin around and around, right? What's that called if you go around the outside of a circle? We have a name for that. It's on our GED formula sheet. Circumference. So do either of you have Nicole, do you have your GED formula sheet on you?
No, I'm pulling it up on my phone right now.
Yeah, you should. Because I have this formulas memorized. I don't need the formula sheet. But I don't want you to try to memorize them. You've got enough going on to remember for your GED math test. I just want you to be able to find the right one. Here's the formula sheet from the GED testing service. All I did was Google GED formula sheet. It's the first thing that comes up. And there we are going to see circumference of a circle. Notice what section it's under. It's in the perimeter section. Why would circumference be in the perimeter section? Perimeter is going around the outside of a shape. So circumference is just the special name for the outside of a circle. So we see circumference there. And what you're going to notice is that we have some options. They actually give us 2 formulas. They say C is equal to 2 pi r or C is equal to pi d. Let me pull it up larger so the rest of the internet can see that. So circumference of a circle, I've got 2 options. I've got C is equal to 2 pi r, or it says C is equal to pi d. Why? Because depending on what I've been given, r stands for the radius of the circle, or d stands for the diameter. So what do I know? So we were looking at a circle with a diameter of 3 meters. We said we wanted the circumference because we were going around the outside of that circle. But we are going to want the one with the d in it. We are going to use the formula C equals pi d. Now we'll plug in what we know. Now, right in that formula sheet, right after the semicolon, it told us an approximate value to use for pi. It said pi is about 3.14. And unless you're told otherwise on the GED, you can always use that. And now d, the diameter of my circle, well, it says my circle was 3 meters in diameter. So I can plug a 3 in right there for d. And now 3.14 times 3 gives me 9.42. So how far would a child clinging to the outside of the merry-go-round travel in each rotation of the wheel? He's going to travel about 9.42 meters per rotation each time he travels in a circle. Let's look at number 6. The Ellisons are building a sunroom addition to their home. The room will have 3 large windows, 3.5 feet by 4.5 feet each. How much weather stripping will they need in order to properly insulate the windows? Once again, I feel like we could use some visualization skills here. You know, I've got some pictures. So let's try to draw this. What does this look like? What does a window look like? If they don't specify, what are we going to assume this window looks like?
Rectangular, yeah.
This is rectangular. But I really want you to be careful. Notice that it says the room will have 3 large windows. I don't care if you draw 3 or you just write times 3, but don't miss the fact that we've got 3 of them. And now these windows are 3.5 feet by 4.25 feet. And it asks how much weather stripping will they need in order to properly insulate the windows. Okay, you have to understand a little bit about language here to know what's going on. Weather stripping. Where do you put the weather stripping on a window?
I want to say around it.
Around it. Yeah, how stupid would your window look if you covered the entire thing with weather stripping? It's gray plastic. You won't be able to see outside of it. You're going to go around the outside of it. What did we say it was called when we go around the outside of something?
Circumference.
Well, a circumference is a circle, but any shape is known as a perimeter. So we're going to find the perimeter of these rectangles. So that being said, you can check out the formula sheet if you'd like, or you could just use common sense. I really feel like we've got the basic operations up here, and we know that, like, if we want to put weather stripping right here, well, that's 4.5 feet. Oh no, 4.25 feet, sorry. And then if I want to put the weather stripping right there, well, that's another 3.5 feet. But I have to put weather stripping all the way around the window or I won't be protected. So how about there? How much weather stripping would that be right there?
4 1/4.
Another 4.25. How'd you get that, Nicole?
It's the same size as the other side.
Yeah, it's going to be the same as the other side, or your house is going to look pretty lopsided. Strong work. 4.25. Then how about here if I want to go there?
3.5.
Exactly, another 3.5. And I can go all the way around the window with my common sense. I didn't even need a formula. To add these up, if you're not very good at adding fractions, you can feel free to use your calculator. This one is actually easier for me without a calculator. So I think I'm going to do it without a calculator because I can just add up the whole numbers: 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. And then I have a half and a half. And I know that 1/2 and 1/2 together makes
One.
one whole thing, exactly. And then I have a quarter and a quarter. Well, 2 quarters together, literally, if you had 2 quarters, you would have a half of $1. So I get a half. A quarter plus a quarter is a half. Okay, and so I get 15.5. Now, you might be saying, Kate, I hate you. I don't add fractions in my head. Okie dokie, pick up your calculator. Let's see if we get the same answer. So to input those fractions, again, I want to make sure that I am in math print mode. Ooh, not in science mode. Sorry, your calculator probably won't be in science mode, but mine was from doing a scientific method video. Okay, so I arrow down over the word math print, press enter to select, clear out of the screen, and here we go. To enter in a mixed number, you want the UN over D button, which is in green. So we're going to hit second, N over D, and then what was our first number? 4.25. And then we got to arrow out of the fraction before we press plus, and then to get another mixed number, again, you're going to press second, N over D. All right, 3 and 1 over 2, 3.5, and we're going to add that with another
4.25. Oh, did you put 4.5?
Oh, I'm so glad you noticed because that's exactly what I did wrong in the last video and got scolded for. Okay, now you know you can actually arrow over to just make one change in a TI. It's so nice. You don't have to clear out the whole thing. Look, I just wrote 4 over the 2. What? Anyway, sorry. Pretend like I did that on purpose for a teaching lesson. Okay, plus, and I'll press second, N over D to get my other 3.5. 3.5. But there it is, 3.5, and I press enter, and I see I got 31 halves.
Girl, when this calculator came in the mail, I was intimidated.
Yeah. Well, people get intimidated because the enter button. First day of class, they're like, where's equals? It's enter. It's going to be okay, guys. We're going to be okay. Okay, so did you get 31 halves?
I did.
Okay, cool. This is the quick convert button right above the enter key. It gives the most common form of answer it thinks you want. You could have also converted this number into a mixed number. So I'm going to arrow back up to 31 halves, press enter to select, and I'm going to use the convert to mixed number here. It's right above times 10 to the n. So I need to press second and then the times 10 to the n button, and it'll say 15.5. So you can convert a decimal or a mixed number. But I still say this one was easier to do in my head.
You're scaring me even more, Kay. I'm like, so are they going to want a fraction? Are they going to want a proper fraction? Or are they going to want a decimal? Or
students like worry about that too much.
One of those students.
They're like, which one is right? That's what you guys are always obsessed on. Which one is right?
Mm-hmm.
And all mathematicians are over here like, all 3 are right. Either we're going to accept all 3 of them or only one of them will be an option. We're mathematicians. We know that 31 halves is the same as 15.5, which is the same as 15.5. We're totally fine with any of those answers. There's not like one right. Now there's one that's more normal. It's more normal to say 15.5 than it is to say 31 halves. But it's not like it's wrong. And it's not your fault. It's your 3rd grade teacher again. I love Mrs. Carson, but she kind of scarred you guys for life, making you think improper fractions were like evil and could never happen. They happen all the time in math.
I'm going to be looking up who my 3rd grade teacher is.
You don't even remember.
Nope. But I will, and I'm going to send her a note and say, look, Kate told me.
Don't you get me in trouble with sweet old Mrs. Carson. I won't get cookies. It'll be awful. Is anybody mad at me? Well, you should be mad at me because I'm not done with the problem yet, and I was trying to move on. I was about to move on, like I was so excited.
Oh,
You
yeah.
know what I'm talking about, that I'm not done with the problem yet?
We have to multiply by 3.
We have to multiply by 3. Maricela, why do we have to multiply by 3?
There are 3 windows.
There are 3 windows. That 15.5 feet of weather stripping for the first one, for the second one, and for the third one. We're going to need that 15.5 feet 3 times. So I get a total of 46.5 or 46.5 feet.
This is the first time they see how you make one by hand.
Oh, that was what threw you, the fractions by hand?
Yes.
If it was ugly fractions like 5/7 and 3/8, I wouldn't try doing it by hand because it would take me a while. But because it was just halves and quarters, it was really easy. I have a lot of contextual knowledge about halves and quarters because we have halves and quarters all the time in real life. So I found that one easy to do by hand. I might not do one with challenging fractions by hand, but I just know, if I put together a half and a half, I get a whole. Or if I put together a quarter and another quarter, I'll end up with a half. And so I think that that one is kind of common knowledge for a lot of people because of money and baking. Let's look at 7 through 8. It says, before leaving for his cousin's house, Juan fills his gas tank with 12.45 gallons of gas for $36.09. His car gets an average of 32 miles to the gallon, and it is 202 miles from the gas station to his destination. The trip takes him 3 hours. What is Juan's speed in miles per hour? So I've done what the GED likes to do, which is give you too much information. So right now we're trying to locate the correct information. So let's go straight to our question. It says, what is Juan's speed in miles per hour? Okay, what information do I need to figure out miles per hour?
You're going to need the 3 hours and you're going to need the 202 miles.
Exactly. If I want to find his speed in miles per hour, all I need is the number of miles he traveled, 202 miles, and I'm going to per that. Does anybody remember when we talked about the basic operations, what per means?
I want to say divide.
It does mean divide. Divide that by the hours. How many hours was he traveling?
3.
3. Bingo. There you go. So let's go for it. 202. Why did I do one that doesn't work beautifully? I don't know. Divided by 3 gives me 67.333, on and on and on. And I'm a little mad at myself because if this came up on the GED, it would have had rounding instructions because there's no natural rounding for miles per hour, except probably your car does not have a 67 point something on the speedometer. Do you guys' cars have point something, or does it just say 67 or 65 or?
I think it just says 67.
Yeah, I'm going to say that's about 67. I really don't have any rounding directions, so there's not one right answer, but good enough for government work.
It gets my anxiety going with all those numbers.
The 0.333333?
No, with all the extra added information and making sure.
You feel like you have to use it all or something?
Well, as soon as I looked at the question, I was like, okay, this many gallons he filled up with, how many, gallons did he get?
Yep. And you're not alone. I have a lot of people who just start randomly mushing numbers together, trying to be good, obedient math students and use all the information. When you're driving down the road, you've got a lot of numbers flying at you. There's numbers all over your dashboard. There's numbers on your radio dial. There's numbers everywhere. You don't just smush them all together and hope for the best. You discern and you look for the one you need. Do you know what I'm saying?
Yeah, I mean, once I stop and I read the question, then I understand it.
So maybe that's the wisdom right there. When you start feeling yourself get overwhelmed, stop and reread the question so it can direct you as to what you need. It's what I was finding. And maybe that's obvious to some students, but I don't think it's obvious to everybody. So I want to write that down. So then let's see if we can use that skill of letting the question dictate what information we use. So it says, how much gasoline does Juan's car probably use on the trip from the gas station to his cousin's house? So we're looking for how much gasoline does Juan's car probably use? So one of the skills that we did in one of our word problem lessons was rephrasing the question in our own words. So what are we looking for here, guys?
How many gallons is left?
Okay, so how many gallons? Now, it's not.
But that wouldn't give you how much he used.
Yeah, it's not how many gallons is left. It's how many gallons he
Used.
Beautiful. Now, notice that I said, how much gasoline does Juan's car
Probably.
probably use? There's that probably idea. So that might suggest that I'm working with a prediction or an average, something that's normally occurring. Does that make sense?
Would that be, could you also do a round up? So if it just happened to be 67.3 in our answer, would that probably mean round up?
Oh, you mean with that kind of vague language? Yeah, if I say approximately or something like that, a lot of times it's a clue to round.
Yeah.
It might have a rounded answer, but what I'm seeing here with the probably is that I might not know exactly, but I have enough information to figure out a good estimate of how much gas he used. Okay, cool. So what information do we need then if we want to figure out about his gasoline? Let's go looking through this problem for information that pertains to how much gasoline he's going to use.
How much his car gets a gallon? So 32.
He gets 32 miles to the gallon, meaning each gallon of gasoline will take him 32 miles.
I feel like we're going to divide
Yeah, what do you want to divide with? What's the other number you want to use?
the 202 miles.
The 202. The reason why you probably feel like we want to divide is this 202 miles. This is the total trip. And we want to take that total and we want to break it down. If he's going 202 miles, the first 32 miles used 1 gallon. The next 32 miles use 1 gallon. The next 32 use 1 gallon. So I agree with you. I'm going to take that 202 total miles, divide by the 32 miles per gallon, and it will put me in gallons of gas. And when we did our interpreting units or using units to interpret word problems, we talked about how the miles and the miles would cancel there with the division, and our answer would be left in gallons. So let's do 202 divided by 32, and I get 6.3125 gallons. And now this is gallons, right? So is it possible to have pieces and parts of gallons?
I want to say yes.
Yeah, it sure is. You can use a piece or a part of a gallon. So I'm just going to leave this here since I have no rounding directions.
Quick question. Whenever I said I want to say we divide, now if we can use the invert of division, correct?
We were saying how many 32s are there in 202? How many times does 32 go into 202? That's what it means to divide. So yeah, you can think about it like 32 times what equals 202. But the only problem is I don't have this multiplication fact memorized. I don't know that 32 times 6.3125 is equal to 202. So this one's easier to just do the division. Does that make sense?
Yes.
Are you sure? Because I know a lot of students get pissed at me for that very statement. Like, how could it be both, Kate? And I'm like, because multiplication is division and division is multiplication, just backwards.
And that's what I get that, but I get so confused because whenever I look at the question, I'm like, okay, we would divide, but we could possibly multiply. But I think that's that inverse of doing either or and getting the same number, but it takes longer.
Well, the good news is, let's say you weren't sure and you said, I'll multiply. If you just took these numbers where they stayed, 32, and multiplied by 202, which is what a lot of students do is their first mistake, I would get this. He used 6,464 gallons of gasoline. And it just doesn't even make sense. He used 6,000 gallons of gasoline to travel a couple hundred miles? What is he driving, a jumbo jet? You know, it just, and so then that instinct is like, oh, maybe I should try the inverse. Do you see what I'm saying? So
now on the GED test, is that something that they would have just to throw you off, or would they just?
I doubt it would be that crazy off, because they're going to know that most students could rule that out without doing the math.
Can we like edit this part out so then they don't add it into the math to throw me off?
I don't want to edit it out because I think that that's a really helpful skill. When a student comes up with an answer that doesn't make sense in their calculator, they should try using the inverse operation. And all the time, I have students who know it's multiply divide, but they're not sure which one. They put the two numbers in and they go, well, that doesn't make sense. So maybe I'll try it the other way around. Number 9, Circus charges $14 for a child's ticket and $22 for an adult ticket. On Wednesday night, they sold 652 tickets and made $11,088 in ticket sales. How many of each type of ticket did they sell? This would be a really mean problem if it weren't multiple choice. If it weren't multiple choice, you would need to use algebra and write some algebraic equations to solve it. However, it's multiple choice, guys. I feel like we could use some of our problem solving strategies with the multiple choice. Any thoughts?
Can we try to find the wrong one first?
Yeah, you want to try to find some wrong ones?
Yeah.
Sure. Let's go for it. Which one of these you want to test? It really doesn't matter.
Let's start with A.
Okay, how could I test this to see if it's a right answer? Well, there's two things I know. I know that on Wednesday night they sold 652 tickets, and I know how much they made in ticket sales. So these two things better be true. So I know that we're supposed to have a total of 652 tickets sold, right? I've got all these answers here. I'm wondering if this A gives me a total of 652 tickets sold.
It does.
It does? How'd you know, Nicole?
I added the tickets together.
You added the tickets together. She said the adult tickets plus the children's tickets better give me 652. So 398 plus 254 gives me 652. Check. Wonderful. So the 652 tickets checked out. How about the $11,088 in ticket sales? I want to know if A works.
No.
No, how come?
Because the first one was $12,312. So that one
Yeah, so what did you do though? 398, the 398 was
Times
the cost of
22.
an adult ticket, so that should have been times 22. And the 254 was the price of a child's ticket, so that should have been times 14. Okay, so let's see. You said it's 12,000 something, Maricela? 398 plus times 22 plus 254 times 14. Yeah, 12,312. That does not give me the right number of dollars of ticket sales. Okay, so let's look at this one. So this time I have 398. Each time I sell a child's ticket, I'm making
$14.
14, and I'll add that together with the each time I sell one of those 254 adult tickets, I make
$22.
22. Wonderful. And if I type that whole thing in, I get 1,000 or 11,160. Close, but not 11,088. Okay, which one shall we try next, ladies?
Let's try the last one because I'm trying the C, and I think that one is wrong too.
C seems wrong. Okay, so let's try D. Okay, so in D, I'm selling 407 tickets, and each one of those tickets these tickets are children's tickets. So I'm making how much?
$14 each.
Yep. And I'm selling some adult tickets, 245 of them, and on each one of them, I'm making
$22.
$22. Let's check it out. 407 times 14 plus 245 times 22. Hey, look at that. 11,088. Maricela had it right. It has 11,088, and we forgot to check that it added up to 652 tickets. Let's just make sure. 407 plus 245. Yes, adds up to 652 tickets, making that much in ticket sales. Sweet. You're right. It is. That was rude. Number 10, it says the Johnsons are putting in stained concrete flooring in their new 18-foot by 22-foot recreation room. The materials for the flooring cost them $1,200 and labor cost them $2,200. What is the overall cost per square foot that they invested in the flooring? So even though this one's not quite as overwhelming as the guy with this information, I would say that this is another case where making sure that we know what we're looking for is really going to help us. So help me out. What's the question here? What have I been asked to find?
What is the overall cost per square they invested in the flooring?
Beautiful. They're looking for the cost per square foot for the flooring. That made me so excited. And again, I swear that I write the problems that I do for a reason. I know what the GED's favorite things are, and the GED loves geometry. This is a geometry application problem. Word problems, obviously this is a word problem, and they love unit rates. Oh, 3 of their favorite things in one problem. Well, I've been asked here to find the cost per square foot. Anytime you're finding a blank per blank, we're looking at a rate. Okay, the cost per square foot, like the dollar for 1 square foot, that's a unit rate. Okay, and we already did one problem like this. How are we going to find the cost per square foot? Well, we're going to take the cost and divide it by the number of square feet. Okay, let's go find what we need. First of all, how much did this thing cost him?
You're going to add 1,200 plus 2,200.
Exactly. Both of these things were part of the cost. So if we want the overall cost, the total cost, we are going to have to add these up together. I agree with you. So 1,200 plus 2,200 gives me 3,400. That's my cost, $3,400. Now I'm supposed to divide that by the square feet. What's the square feet here?
396.
Hey, Maricela, where'd you get that number? That number's nowhere in my problem. Where'd it come from?
I just multiply 18 by 22.
She multiplied 18 by 22. Maricela realized something. We don't know the square feet. What we know here are the dimensions of the room. We know that the room is 18 feet one way and 22 feet the other way, probably roughly rectangular. So if we want the square footage, we have got to multiply. Square footage is area. And so we have to use those units there to know they're actually wanting us to use the area, 396 square feet. Now that was tricky. So anytime they ask you for square units, whether it's square inches, square meters, square feet, square yards, the thing we measure in square units is area. Okay, wonderful. So I'm going to do 3,400 divided by 396, and I get this ugly number, 8.585858. This is 8.585858 what?
Dollars.
It's dollars per square foot, right? So we have dollars per square feet. So it is dollars. And so I say that I need to round. Where does money have to end, y'all? I can't have decimals going on forever and ever in my money. My decimals have to stop where?
The second digit.
Absolutely. 2 digits after the decimal place. We call that the hundredths place. So 2 digits after my decimal, I consider the next number the one I'm about to throw away. It is 5 or higher. It's big enough to matter. And so I'll say that's about $8.59 per square foot. Is anybody mad at me?
No.
Probably should be. That was really challenging.
That's so dumb.
Why is it dumb?
It just bothers me because are we really going to use this in real life?
Well, actually, I would use that if I was comparing the size of something. So, for example, when I ran my restaurant, I very much used the cost per square foot to decide which was the best rental. When you look at rentals, your agents will tell you, oh, this one's 97 cents per square foot. In this district, in this warehouse district, you'll get about 50 cents per square foot. But in this high traffic foot area, it might be $3 per square foot. So I was in downtown Honolulu, which is a really expensive neighborhood, and our rent cost was almost $11 per square foot a month. And it was something that we had to know to compare our prices of different locations.
You know, do it like thinking like if my husband is putting like flooring in our home.
Mm-hmm.
It's how I use it, or even the size of the bedrooms that are very small.
Yeah.
Nicole, one thing that helped me a lot when I was doing my GED test was thinking in like real life, because it was so hard to me to understand some stuff, and Kay was talking about money, about like buying groceries or clothes, and it just goes so easy.
Yeah, that helped you.
Yes.
You guys, I had a student years and years ago with severe math and learning disabilities. She's still my good friend to this day, and I love her. She did pass her GED, okay? But she had to finally go and write a $sign next to every number she saw. Because even though she was horrible at math and had all these learning disabilities, she had been a single mom for so many years that by necessity, she had to be good with money. So just by putting a $sign in front of all these things that did not have anything to do with dollars, she was able to relate it to money and finally pass her test.
That's me. Even with percentage, like 50% or 30%, I was just thinking in discounts.
Yeah, Mary says like, I always go shopping, girl. Sweet.
You guys are giving me great ideas here.
Good, I'm glad. Okay, so let's look at number 11. I don't want to freak you out with 11 and 12. They're challenging problems and they fall under the heading of algebra. But you can use simpler values to think about them, and that's what we tried before. So let's look at 11. It says 3 siblings pitched in their money to purchase a gift for their mother for Mother's Day. The youngest child gave $10 less than the middle child. The eldest gave 5 more than twice as much as the middle child. Now it says if the middle child gave $m, which expression represents the ratio of what the eldest child gave to what the youngest child gave? There's a lot going on in this problem, but one of the hardest things is that we don't know how much the middle child gave. What we know is that he gave $m. And a lot of students just freeze up and freak out when they see letters. And Nicole, not to point a finger at you, but you might be one of them. Anybody who's had some negative experiences with algebra just tends to freak out. So I always say, don't freak out, try it with a real number first. So let's imagine that the middle child actually had some amount that we knew. Let's say like the middle child had $30 the middle child gave. Okay. Now I know that's not really true. I know the middle child didn't really give $30. The middle child really gave $m. But thinking about it as a number I understand is going to make my life easier. When when I go to think about this. It says the youngest child gave 10 less than the middle child. Guys, if the middle child gave $30, how much did the youngest child give then? What's 10 less than $30?
20.
20. How could I get to that number? What did you do to get to that number?
Subtract.
Yeah, you took that $30 and you subtracted out the 10, right?
Yeah.
So even when it's a number we don't know, like M, we can take that M dollars, subtract out the 10, and that would represent the youngest child's money. Now let's do the same thing with the eldest. It says the eldest gave 5 more than twice as much as the middle child. 5 more than twice as much as the middle child. If you wanted to figure out how much the eldest made when we had 30 bucks, it's 5 more than twice as much. What would you do?
Multiply.
You would multiply the 30 by 2, absolutely, and then add on the 5 bucks. So we can do exactly the same thing with when it's M instead of 30. We can say we'd take 2 times that M, that middle child's amount, and then add on the 5 bucks. And this gives us the, who was that, the eldest? Oh, wouldn't you know it, the eldest is giving the most. Okay, so here I have all these numbers now to represent these guys. So let's take a look now. It says, which expression represents the ratio, and I hope you guys know by now that ratio just means make a fraction, of what the eldest child gave. So I want the eldest child on top to what the youngest child gave. I want the youngest child on the bottom. So you guys told me that the expression we could use for the eldest child was 2m plus 5, 2m plus 5, and then the youngest child was m minus 10, m minus 10. So the correct answer there is D. Woo, that was rough.
So when you did the first part and you put m minus 10, I mean, couldn't we just stop there because D is the only one that has it?
D is the only one that has m minus 10?
At the bottom.
At the bottom where it needs to be? Yeah,
Yeah.
absolutely. When it's multiple choice, you can totally do stuff like that. And that's why even though writing expressions is really challenging for GED students, even students that don't have a lot of practice with algebra can usually, if they just don't freak out, puzzle through it and figure that out for reasons just like that. But I did try to trick you with B. You know, I was really trying to get you, because most students, when I say 10 less than the middle child, do that. They go 10 less than the middle child.
But I was thinking it was C because I don't put attention reading.
Oh, on the order? Okay, I'm going to deal with C in just a second. But B's wrong here because, like, if I started with 30 bucks and I wanted 10 less than that, I wouldn't do 10 minus the 30. I'd do the 30 minus the 10. So sometimes using a number we understand can help us understand the order for that. So 10 less than M isn't 10 minus M, it's M minus 10. So I was trying to trick people. Now, Mary Stella's question, that is straight up language with ratio that you have to understand. If I say the ratio of the eldest to the youngest, that means I want the eldest on top and the youngest on the bottom. If I wanted that M minus 10 up top, I would have had to ask you for the ratio of the youngest to the oldest. Oh, good. You're going to love this one then, because this one's even more challenging than the last one. It says Juan is 3 years younger than his sister Marie. Their father, Paulo, is 9 years older than twice Marie's age. If the sum of their ages is 58, which equation below could be used to find M, Marie's age? So once again, this is challenging because they're asking me to write an equation, and I don't know this M. I have this mystery M. But we've said before, if you don't understand something, just try replacing it with a simpler value. So let's pick a value for M.
10.
What?
10 again?
Sure, 10. Okay, so you're saying Marie. We know she's really M years old, but let's pretend that she was 10. Let's use a simpler value in order to understand. It says Juan is 3 years younger than his sister Marie. How could I get from 10, Marie's age, to Juan's age, 3 years younger? What would I have to do?
Subtract.
Subtract what from what? Order matters in subtraction, Nicole.
10 minus 3.
10 minus 3. You'd like me to start with the 10, that's Marie's age, and subtract out the 3. So I agree with you. I can do the same thing when it's algebraic. I can start with the M, which is Marie's age, and subtract out the 3. That'd be Juan's age. Now let's go to their father. Their father, Paulo, is 9 years older than twice Marie's age. That's tricky. 9 years older than twice Marie's age. Well, if Marie was 10, how old would Paulo be?
I don't understand that. 9 years older than twice. I feel like there's addition plus multiplication going on.
There is. That's exactly what's going on. Addition and multiplication. Twice means 2 times as much. So twice Marie's age would be 2 times 10. But he's not just twice Marie's age. He's 9 years older than that. So I would have to add on the additional 9 years. Now, if I wanted to write this though, using not the number 10, but the letter M, how would I write it?
Multiply 2 times m plus 9.
Good. 2m plus 9, that represents Paolo's age. So now we have Marie's age as m years. We have Juan's age as m minus 3 years, and we have Paolo's age as 2m plus 9 years. We've used the simpler values in order to make sense of the algebraic values. Now we can do what they've asked us to do, which is what? It says the sum of their ages is 58. What does sum mean?
The overall answer,
The overall answer when you do what?
when you add it,
When you add. Sum
Okay.
means an addition expression or an answer when you add. Absolutely. So what I'm asking you to do with these ages is to add them, to sum them. I would need to sum Marie's age. And how old did we say Marie is? Don't be scared to say a letter. How old did we say Marie was?
m,
M. Marie is M years old. I'm going to add that with, how old did we say Juan is?
3 years younger, so minus 3, m minus 3.
M minus 3. You need the M. If you just put minus 3, then you're saying that Juan is negative 3 years old. So super important we have the M minus 3. Cool. And we're supposed to sum those. So I need to add those with Paolo. How old did you say Paolo was?
So does it say m plus m?
Right now it does. M plus M minus 3. This is me just saying there's Marie's age, M. There's Juan's age, M minus 3. And I want to add that. I want to sum that with Paolo's age. What's Paolo's age?
2 times m plus 9.
2m plus 9. Okay, and we said that the sum of all those is 58. Huh? And I can see which one of these makes sense then. Can you see which one of them makes sense?
Yes, number 8.
Absolutely. We have Marie's age summed with Juan's age, summed with Paulo's age, and it's equal to 58.
But why are we putting an m at the front?
For Marie's age, I'm supposed to sum all their ages. It says if the sum of their ages is 58.
Got it. Marie has to have an age too.
Exactly. Is that cool?
No, but whatever.
Well, you might be mad at me because the last problem, the letter didn't get used by itself. So this one just says the sum of, maybe I should say all their ages. Would it be clearer if it said the sum of all their ages so that you knew Marie was included?
I think so.
Okay, so then that's just a weakness of mine being a not very good word problem writer. That's the GED, believe me, is vetted. So is that clear now if it says the sum of all their ages is 58?
Yes, because then I know Marie needs to be included.
Okay, cool. Now this other one, I knew they weren't included because it says which expression represents the ratio of the eldest child to the youngest child. They didn't ask me for the middle child when they asked me to write my answer. So I didn't have the M by itself in that particular one. Okay, little mean. All right, so thank you so much for joining me in our review class, our very last class for interpreting word problems. As you see, word problems on the GED can get pretty tricky. They're varied. There's a lot of interpretation skills that go into them. So I hope that you will practice this until you feel like a word problem ninja. All right, see you next time.